Hi, this movie is for proving the Pythagorean theorem using similar triangles. So the first thing we need to know is to remember what the Pythagorean theorem is. The Pythagorean theorem is when we have a right triangle. Here we have triangle ABC. It's a right triangle because we have a 90-degree angle. The side lengths, you'll notice side length A is a lowercase a because it's opposite the angle with the capital letter A. Also with C, and B is also across from angle B. We have two legs. The two legs are the two sides that form the right angle, and we have the hypotenuse, which is the longest side or the side opposite the 90-degree angle. What we know with the Pythagorean theorem is that the two legs squared equals, the sum of the two legs squared equals the hypotenuse squared. That's what the Pythagorean theorem is. So that's a quick refresher. And what we're going to do now is look at similar right triangles. In this diagram, there are three similar triangles. ABC, let's highlight triangle ABC. ABC is this large triangle. And you can see with the large triangle, ABC, we have the hypotenuse, we have the short leg, and we have the long leg. Hypotenuse, short leg, and long leg. Now the legs being the two sides that form the 90-degree angle, one is going to be short, one is going to be long. So that's our first triangle. It's similar to triangle CBD. CBD is this triangle. Now that triangle has a short leg, a long leg, and the hypotenuse. Notice where the right angle is. It's over here by point D. And then we have triangle ACD. ACD is this middle triangle, medium. So you have the small right triangle, the medium right triangle, and the large one. This one has a right angle here at point D with the short leg, the long leg, and the hypotenuse. So that's the diagram we're going to use. And what we're going to do here is we are going to compare triangle ABC to triangle CBD, writing a proportion for the short leg. Let's put short leg over the hypotenuse. So for each triangle, we're going to do that. For ABC, let's look at ABC. It's the yellow triangle. The short leg is side A. You see that? The short leg is side A. I'm looking right here. So what we do is we put for the short leg here is side A. The hypotenuse for ABC is side C. So I'm going to put a C down here. So short leg over hypotenuse is A over C for triangle ABC. So this was with regard to triangle ABC. Now I'm going to do triangle CBD. That's the small triangle. And in the small triangle, the short leg is the value of X because that's BD. So I'm going to put X. You can see that here. X is BD. Then the hypotenuse of that small green triangle is this length BC. So BC is really length A. So the short leg to the hypotenuse of the green triangle is really X to A. Now cross products means that I multiply across. I get A squared is equal to CX. Let's try that down here with triangle ABC. Triangle ABC is the yellow triangle, and I'm going to put that here. And then I'm going to compare that to ACD, which is the pink middle triangle. And what I'm comparing is the long leg over the hypotenuse. Long leg over the hypotenuse for each of those triangles. So in triangle ABC, the long leg is B. So B is 2. The hypotenuse is C of the yellow triangle. Now I'm looking at the purple triangle for ACD, and the long leg for the purple triangle is this length of Y right here, DA. So I put Y over the hypotenuse, and the hypotenuse of that purple triangle is the length B. Then cross multiply and put your results in the box. So I'm going to multiply across, and I get B squared is equal to CY. Now take what is in the two boxes and add the two equations. Then you will need to simplify the results. So what we have here is that A squared is equal to CX, B squared is equal to CY, and I'm going to add these two equations. So over here I get A squared plus B squared. Over here I get CX plus CY. This is just A squared plus B squared, and you can see the common C in both. So I'm going to distribute out a C and get X plus Y. Now if we look at our diagram up here, see what X plus Y is? X is this length here. Y is this length here. If I add those together, I get this entire length, BA, which is my hypotenuse, C. So I'm going to go down here and replace this X plus Y with C. So I get A plus B, A squared plus B squared, is equal to C times C. That's A squared plus B squared is equal to C squared. And what is that? That is the Pythagorean theorem. So this is a proof of the Pythagorean theorem using similar right triangles. Make sure that you take a picture of this to turn it in. Thanks for watching.